So today we'll go to the fingerprinting based systems, which is another kind of indoor positioning system based on the fingerprinting maps. So this part will be divided into several parts. First we'll introduce the subject, then I will define the fingerprint map and its content and how we can build it in the next part, the database generation. Then we'll have a quick peek on simultaneous localization and mapping, SLAM. Then we'll talk about fingerprint matching, which is the core part of this kind of system. And then I'll present to you a hybrid model which merges a fingerprinting system with a GNSS-like system. So first, I'd like you to keep in mind this picture here, which shows the choices that you can do when you design a positioning system based on Wi-Fi. So first you have to choose your global algorithm, which can be GNSS-like with all of the properties we already saw in the previous video, or fingerprinting here with three main properties: the fingerprint composition, the database generation, and the fingerprinting matching. So we'll see that in details, but fingerprint composition can be with single values or multi-values, which can be aggregated in various ways. The database generation can be either empirical, which means that you perform real measurements, or simulated, following a propagation model. And the fingerprint matching can be either probabilistic or deterministic. With a deterministic matching, one input always gives the same output, while for the probabilistic system you may have varying outputs given your inputs. So first, why use fingerprinting? We just saw that propagation-based systems, which also stands for GNSS-like systems, are not accurate enough for indoor positioning systems, since they do not include topology description. They cannot simulate various noise that can be included in the signal. So one of the solutions is fingerprinting. Fingerprinting relies on a database in which we associate RSI samples to known locations. So basically we map the RSI samples to known locations. Then we locate the device by using its own sample, which has no location associated with the content of the database. So this is the fingerprint matching, and the most similar sample in the database will use its location as the mobile device location to give the estimate of the mobile device location. So with this kind of system, since we make measurements or simulate the propagation, the topology is implicit because we include in the database values which take into account the topology without needing to do that online when you use the system. How does a fingerprinting system operate overall? So you have several steps. First, you define the RSI fingerprint database. So you have to choose the symbology and reference of the locations. So how do you represent the locations? Then you have to choose how your RSI samples are stored, if they are single or multi-valued and so on. You may add information which are optional but can improve your positioning. Second step, you have to fill the fingerprint DB, so you can either use empirical or simulated way, so you have to choose your method and choose the density of the database. So how many points do you store in the fingerprint database for a given area. So this is of course a trade-off with the cost, which means that the more dense, so the more points you have, the more time you need to build the fingerprint database. Last and third step, you have to use the fingerprint database to locate devices. So first you get an RSI sample from the device, then you find the most similar sample in the fingerprint database, and you return this fingerprint location as the location of the mobile device.